Good afternoon. I'm Thomas Brickner, the instructor for the online section of Astronomy 2002 for fall semester 2019. In this little video, it's kind of a mini lecture, I guess, just going over the uh, basic startup procedure for the semester and a few things that are ahead for us. So let's get to it. A lot of you may be thinking, well, why am I here? And of course, the answer to that is you're here because of the GEP program, General Ed program. And this course fulfills Science Foundation E1. And it's a descriptive survey of the solar system, galaxies, and the universe, physical properties of stars, the HR diagram, stellar evolution, black holes, and neutron stars. And so that's the formal course definition from the course catalog. And we'll be covering most of those topics this semester. Now, the first week is kind of topsy-turvy. People are dropping, they're adding, they're coming in off the wait list, you know, et cetera, et cetera. So I keep the first week pretty simple. The first thing you want to do is take the attendance quiz. And that's homework zero. That's not part of your semester grade, but go in and it's a Chuck Norris question. Just go in and answer that, see if you can get it right. And in case you don't know, that what they're looking for with the attendance is clicks. So even if you don't get the quiz 100%, it's still good enough for attendance. Because it's just, what they do is on the Saturday at the end of the first week of classes, they go in and they comb through web courses for every class for every student to see if they've been clicking, and that's how they know that you're engaged with the semester. The other thing you can do is start skimming the free textbook. That's right, we're using a free textbook this semester, and it's actually embedded in web courses. It looks like this. It's from the OpenStack system, and we've used it in prior semesters. Here's the home page, and if you go down towards the bottom of the home page, you'll see a link to free textbook. Okay, now what that does is it goes to the modules page, and on the modules page, you'll see the front matter, chapter 1, chapter 2, etc., etc. So you can go down to chapter 4, for instance, and click on something. And just look at the diagrams, start looking at images and diagrams and so forth. There's it's chapter 3.4, figure 1. That's an image or a diagram of different orbits of comets, asteroids, and some of the inner planets. There's Halley's Comet, the famous one. So you can look at all that stuff. Just, start skimming around. And later in the first week, I'll put in place some homework and some actual lectures to go along with, to start the semester off. You'll also see in the book, in the free textbook, a lot of my annotations, like this one right here. And if you pop it open, it'll give you, this one's it links to homework number 3. And we won't have homework 3 ready for a couple weeks, but I mean it's already in there. And when you get to that part of the text, you can click on it and do homework 3. And the annotations that you'll see are from summer semester, so they're pretty good to skim as well. And familiarize yourself with it. That's a good way to put it. Also familiarize yourself with the syllabus page in web courses, and that's in lieu of a handout that you normally get in a lecture class. Now, as far as astronomy ideas, there's two things I want to review with you today quickly. And the thing is, we're going to be talking about these things all through the semester. Everybody's interested in black holes. Ooh, what's happening with black holes? And just recently there was news that they finally got an image of a supermassive black hole in a galaxy called M87. Very tough to do, but they got it. And they're also trying to find an image of the supermassive black hole at the center of the Milky Way galaxy, our galaxy. And they know where it is. It's just hard to image. Um, But so, and we're going to be talking about black holes in the last week of the semester. That's always where we finish. And it's a cool topic. Everybody likes to learn about it and stuff. But really, the thing that for us is important is that getting on the trail of black holes and stuff starts in the solar system. For instance, we look at the chemical and the nuclear composition of planets and asteroids and comets, even. And that stuff is very, very important for studying planets, of course. I mean, here's one compound called, or a mineral called olivine, and that's found in, around Earth and Mars. Uh, and Earth's mantle is a big component of Earth's mantle and crust is the mineral olivine. And you see it in a lot of igneous rocks up here at the surface too. So the interesting thing is that when you analyze the chemical and the nuclear composition of all the substances that you can see and find, like you put a rover on Mars, you analyze its chemical and nuclear composition. You put um, you get some moon rocks and bring them back from the Apollo mission. You study the chemical and the nuclear composition and stuff. Here's a real cool method that they did that a few years ago, back in the early 2000s. They took the Stardust spacecraft, they launched it, and basically they lobbed it at a comet called Wild 2. And this little tennis racket shaped dealy bobber here is what they sent it out there to do. I mean, that's their collecting device. They flew this spacecraft through the tail of the comet Wild 2, and their hope was to collect inside this tennis racket shaped deal uh, some grains of comet dust. And what they found was really interesting. Here's a map or a diagram of the orbit of Stardust and the orbit of Wild 2. You can see Earth's orbit, and then down in the middle, you can see the yellow circle. That's the sun. And, Stardust, the spacecraft made a couple, three loops around the Earth. Now, each time building up a little bit more speed. And finally, on the third loop, it got out to Wild 2 and it flew through the tail of it. And here's the tennis racket. And in the upper left, you can see a person's hand, their fingers anyway. So this thing is, I figured it out. The diameter is uh, maybe about 14 inches or so. It's not a circle, but so if you took your laptop and put it on top of this tennis racket deal, it would, pretty much cover up most of this device, the collection device, tennis racket. So they flew this thing through there, and then they got that, and then they got it back to Earth, and it landed, and then they analyzed all the little submicroscopic particles. They needed an electron microscope for most of them, but they analyzed all that stuff, and it's kind of interesting because what they found was a little teeny speck of material that they figured out could not have been from the solar system. It had to have been from another star, a red giant star, far, far away, and probably billions and billions of years ago. And the thing about it, they know just from understanding that little grain that they found in a solar system mission, they're able to figure out, like a trail of breadcrumbs to another star, and it happens to be a red giant star. Now we don't know which one. It's not there anymore because it went into supernova. That's why all its particles are scattered around the galaxy and ended up in comet Wild 2 and probably a lot more in various places around the solar system. But the interesting thing is that our mission to study a comet revealed this grain that came from a red giant star that went into supernova detonation and probably left behind a black hole. So all the things that we collected from WOW 2 informs most of the topics for this semester. All right, so these the nuclear and chemical composition of the planets and comets and asteroids and stuff. We're going to be talking about it all the time, even out to the last week of the semester, all right? Because it's always going to be a subtext of pretty much everything that we talk about. Now, here's another um, important idea I want to share with you. This is the second idea, and it involves meteorites. And one of the cool things about meteorites is that civilians find most of them. Here's a bunch of scientists down in Antarctica uh, uh, looking for meteorites. Antarctica, if you look at it, it looks, I mean, it's all snow there, but it looks like a desert. I mean, you see deserts covered with sand, and Antarctica is like a desert covered with snow. And for that reason, it's easy to find uh, uh, meteorites, especially stony ones. And there's been some really famous meteorites found in Antarctica. Another place they find it is in northwest Africa, the Sahara Desert. Now, this little baby, NWA 2626, was discovered in Algeria back in 2004. And this one, they figure, is a chunk of Mars. It's an igneous rock, and having put landers and rovers and orbiters orbiting Mars um, over the past 40 years or so, we kind of know the makeup of a lot of the geology on the surface of Mars. So when this one came to Earth and we analyzed it, and we thought, oh, this has got to be a chunk of Mars. They even know where the volcano is. They think it's in the Tharsis region of Mars that this thing got blown out. It might have been from a volcanic eruption, or it might have been a fragment of a volcano that got blasted into space and eventually came to Earth, but blasted into space by like an asteroid impact or another of some size. And that can happen. We've collected a lot of chunks of Mars, and we've got chunks of various big asteroids from the asteroid belt as well. So now the cool thing about this is it's called NWA 2626, right? It was found by a civilian in Northwest Africa. That's what NWA stands for. Northwest Africa 2626. It was in Algeria, and somebody in Morocco sold it to a collector, and then they've been studying it since then and figured out that it's from Mars and all that stuff. But most of this stuff is done by amateurs. And so this brings to to focus one of the nice things about Astronomy 2002, and that is after being in this class and reading and learning, you can become an amateur astronomer yourself. In fact, a lot of students, they come in, they didn't know anything about astronomy, and then they get really intrigued and stuff. And here's a star um, a star outing. It's not night yet, but it's up in New Jersey in a park. They're getting ready. You can see it looks like a camp out actually, and they've got all their astronomy, their telescopes and stuff getting ready. And hopefully the skies stay clear and they're able to observe and stuff. But there's tons of amateur. I mean, there's one in my neighborhood. They meet in a park just down the road from my house, and there's tons of that, and it's lovely. It and so if you take an interest in this, just go for it. And we um, we have the UCF Astronomy Society, and you can join that. And I'll have a little word to add about that in a few minutes. But the thing is, when you see it in movies, here's this famous movie, Deep Impact, from about 20 years ago. That's Elijah Wood when he was a shrimpy kid. And in the movie, he's an amateur that was at a public observatory session, and they found a comet that they figured out was going to impact the Earth, and that's the that's how the story began. But that's real. I mean, people, there's a ton of observations and discoveries by us regular civilians. I'm not an astronomer. I'm an astrophysicist. So that means that I write equations and computer programs to simulate black holes detonating and stuff like that. But I'm not really a telescope astronomer. But I am an amateur astronomer, and I know all I've been stargazing since high school, and so it's perfectly good for us starting in Astronomy 2002 to start with that. So I encourage you to take an interest in and just join the club. Now let's go through some of the basic procedures for the semester. Like exams and stuff. Now your midterm exams, the schedule's published already, and we'll go over it again here in this YouTube. You're going to be viewing and studying lectures um, in YouTube. You'll be also reading and studying our free textbook, and after that, you'll have possibly some homework to do. And so between viewing and studying the lectures in YouTube and reading and studying the pertinent sections in the book that's embedded in web courses, you'll be able to tackle some homework. That'll be in web courses too. And we're not going to have a ton, but we will have some. A little bit for each midterm. And then, after you do the homework, you might decide, I better go back and re-listen to a certain lecture in YouTube, or you might want to go back and restudy a section of the textbook, and then go take the homework again, because the homework you're going to have at least 4 attempts, and sometimes more, depending. And so you do that, go through that cycle a few times, and then you're ready for the midterm, hopefully. And a side note to that is we'll also have online office hours, and usually we'll have 1 or 2 before each midterm. And you can, log on, and it goes through Adobe Connect. It works pretty nicely, and we just talk things over and work out problems, calculations you might want. We're not going to have a whole ton of calculations and stuff, but we will have diagrams to interpret and a few calculations to do, and a whole lot of different concepts. And we talk about those in office hours, and then you take the midterm. Now let's talk about um, a little bit more about midterms. Here's a table of all the different tasks that you'll have for this semester. So homework, you're going to have 50 points worth of homework. Now, we might not have 50 questions. We might have, like 62 questions or 37 questions, but I'll scale that proportionally by percentage to some number out of 50 points. Okay, and that'll be 20% of your grade. Then we'll have midterm 1, 2, and 3, and we'll keep the best 2 out of 3, 50 points each, and so 100 points total. And so that'll be 40% of your grade. And then the final exam, 100 points, and that'll be another 40% of your grade. Total of 250 points for the semester. And usually at the end of the semester, I traditionally assign 1 or 2 bonus point assignments, to study for the final. And but those are just 2 or 3 bonus points, nothing fancy. But 2 or 3 bonus points will be very happy. Well, you'll be very happy if you get them, especially if you're near the borderline. Borderline, yeah. Here's the grade scale. Um, so out of 250 points, if you have 225 or more, that'll be a semester A. 188 or more, that'll be a semester B. Now this is at the end of the semester after the final. Right. So, but before then, you don't, you know, after the first midterm, you've got a 50-point midterm. You don't have 250 points possible. So 250 points possible is at the end of the semester. Anyways, 188 for a B. 150 points or more, that's a C. 125 points or more, that's a D. 50% of the possible points. Below that is an F. Now, most students in this class are going to score at least a C for the semester. And although you're going to probably feel nervous about your grade towards the end, but what I found is that I don't hand out a lot of D's and F's in this class most semesters. And those that do get an F, and even the students with D's, usually it's because they're not doing their homework. That's a big chunk of change, 50 points out of 250. So if you don't do the homework, and if you have a little bit of stinkiness for your midterms and the final, it's going to be hard to get a good grade. All right. But if you do the normal amount of homework and faithfully so, and do the normal amount of studying, you might not get an A, but you're probably not going to flunk. Right. So, so take encouragement and just keep working nice and steady. Don't leave everything till the day before the midterm. That's the way to get a D or an F for the semester, because you're gonna take a total face plant on the midterm if you do that. Another thing about this, I don't grade on the curve. I don't have to. Now, these grades usually sort themselves out pretty nicely. So don't even ask me about it. I don't grade on the curve. Now, you sometimes see this. Nothing is written in stone. Wrong. Here's something that's written in stone, our exam schedule. And I want you to take it very, very seriously. I want you to engrave this in your mind. September 19th for midterm exam 1. October 17th for midterm exam 2. November 14th for midterm exam 3. And then the final exam on December 7th. Now, the 3 midterms are on Thursdays. And the final exam is on a Saturday, so just keep that in mind. Just put it in your calendar and you'll be good. Now, the midterms, I usually have them available to start at 10:05 a.m., but you can start them at any time up until about 11. You get about 60 minutes usually for each midterm. So if you start at 10:59, you'll have 60 minutes before the deadline at 11:59. But you can do it in the middle of the afternoon, whatever works good for your schedule. Now, the final exam on Saturday, December 7th, it's a little bit bigger, so you have a little bit bigger window of time. I usually start those at about 8 o'clock in the morning. So keep that in mind. Now, one thing I want to emphasize with you, this is written in stone, as I said. There's no makeup exams. There's no early exams. There's no late exams. There's only these exams. All right. We got a big class, and so we're keeping everything as simple as we can. And this is the schedule that you're going to stick to. Now, if you just you have a job in Hawaii for the weekend or something, and you absolutely can't make it because you're flying across the Pacific, well, then that's going to be your dropped midterm, all right? And that'll be effectively a 0, and then that'll be the one that we drop. And then you better have some good points on your other 2 midterms. All right, but most of you will be here and take all 3, so that's good. And we'll just keep the best 2 out of 3. All right, and so that's good. Now the final exam is mandatory, so that one doesn't get dropped. Matter of fact, let's go and just reinforce a few concepts. It is cumulative, and you're going to feel like the midterms are cumulative too, because, for instance, we're going to always be talking about chemical composition of something and the nuclear composition of something, whether it's a planet, a star, or a black hole, supernova remnant. So, there's certain things, Kepler's third law of planetary motion, we're going to be talking about that all semester. So, but anyways, the final is mandatory and cumulative, Saturday, December 7th. That's the university free period. And as I said, it's available earlier, 8 in the morning. That's 20 hours. So if you have a job off campus, that's more than enough for you to do an 8-hour day and still have 12 hours to get back home, get a little bit of rest, get some food, and then take the test. Right. So, but you've got to plan now. So take the exam schedule and go to your BOSS. If you work off campus, you work at Disney or wherever you work, Longhorn Steakhouse, and just tell the boss, this is my exam schedule. I've got to have time on this particular day, and then you figure it out with your boss, because we don't have any leeway. Our schedule is fixed. So another thing I want to mention to you, even if you feel a little bit of time pressure on the midterms, usually the final's a little bit better because it's double the size. It's 100 points, but you get more than double the amount of time, 170 minutes. So that's pretty nice. That's a standard UCF final exam time. Now, before I go on, I want to talk about civilian amateur astronomers again. And that's the UCF Astronomy Society. Have you ever wanted to look through a telescope, tour a working observatory, or launch a weather balloon into the stratosphere, which is a good way of observing, distant galaxies and stuff? Well, that's what the Astronomy Society does. They do that every semester. So they have frequent meetings, public observing nights, which if you know, you're you're in the online section, but if you live around Orlando, you definitely want to go to one of the public observing nights, because they're very, very important. That you'll look at stars, planets, the moon, maybe even a comet if there's something nearby. Can't tell with comets. And you see galaxies. It's really good. They have it set up. They have a bunch of smaller telescopes out on the lawn in front of the observatory, and then up inside the observatory they have the big observatory telescope, and you'll be using that as well. It's pretty cool. Astronomy camping trips. I cannot verify if those are fun or dangerous in terms of what happens on campouts. But anyways, it's probably fun. Dark sky festivals. They just basically they go different places around Florida or up in Georgia, anywhere around away from the city. You go up into Ocala National Forest, in fact, just a few miles outside of Orlando to the north, up by Paisley and up that way, Altoona. And you go out by a lake, you'll see a lot of it'll be nice and dark if the sky is clear, if there's no clouds. You'll see all kinds of stars and the galaxy and so forth. So here's the web course, or the social media, Instagram, Facebook, and whatnot. There's their website. And I'll have some blurbs on them, and we'll announce when they're going to have the public sessions. And they're really fun. You'll have a lot of fun if you go. All right, there's a lot more to study. I'll see you inside web courses, and that's all for now. Welcome aboard.